Hello! Today we're going to be taking a look at my Gamo Phox Mark II PCP air rifle. It is in .22 caliber, sub 12 UK model. This is completely stock. I have had mods on it. This is not how it usually looks. I reverted it back to stock prior to making some guides on disassembly, reassembling, tuning tips, that sort of thing. So this rifle is now back in stock, and it gave me the chance to think about a little experiment whereby I wanted to investigate something that is shown less so on videos, and that is the transfer port when it comes to tuning. So I have with me a custom transfer port that I got from eBay. It was purchased for about £12, something like that. I can put the link in the description. It was specified at 3.5mm ID when I ordered it, although the calipers here are showing it at 3.36mm ID. Still larger than stock. Stock ID in these UK models, I think, is about 2.25mm or 2mm. I don't think it's as much as 2.5. But I can check that when I remove it. Essentially, what I'm going to do is I'm going to take this transfer port, put it into the rifle, shoot a shot string with this and only this change, no hammer spring change, no regulator change. I'm going to compare that to a stock shoot I did yesterday after reverting this rifle back to stock. So the only thing that will have changed is transfer port size. We're going to look at the power curve, try and see the differences in shot numbers, power levels, spread, and we'll discuss as well at the end of the video. So I'm going to go ahead and strip the rifle down, pop this new transfer port in, and we'll see how the shots come out. Okay, just about to fire off the first shot. Previously at the stock transfer port, first shot was at 163 meters per second. .166 recorded on first shot. So testing continued, running all the way down from 2800 psi fill pressure down to 1250 psi fill pressure. The previous stock shoot that was done had an initial fill pressure of 2800 psi and it finished up at 900 psi. Now, the reason I couldn't get a direct comparison between the two, since I stopped at 1250 for the test of the increased transfer port size, is that I basically run out of pellets of the same weight and batch that were used. Therefore, I think it would be an unfair test if I was to move on to different pellets. So by recording the velocity across the chronograph with each shot that was taken, the magazine the shot was part of, and the pressure in the tube at the end of the magazine, this data was put into Excel, which was then used to put into ChatGPT, which generated a bunch of graphs and information for us to look at and compare test A and B, A being the stock port size and test B being the enlarged transfer port size. A versus the cylinder pressure left in the tube. So looking at test A, first of all, the blue line, which was the stock port size, velocity starts off about 163-ish meters per second, climbs to about 171, 172 meters per second, and at peak velocity at about 1750 psi pressure in the tube. From that point, the velocity slowly starts to drop off, although the spread is not horrific. That is the peak energy there at 1750. If we correspond and look to the same behavior, the velocity of test B, the enlarged port size, the initial and the final speeds are both greater, but the flat line is also a larger range. Velocity seems to go up between 2800 psi until 2250 psi. Then it stabilizes and it stays roughly in the same range all the way until about 1250 psi ish, maybe 1400 psi actually, if I'm looking closer. Essentially, this is a much steadier behavior, but over a shorter range. And when we convert this velocity graph into a foot-pounds of energy graph, taking the projectile weight into consideration, the following graph is obtained. It's essentially the same thing, showing that test A average energy is approximately 9.2 foot-pounds of energy until it starts to tail off after its shot number 80. Test B, the transfer port enlarged, we can see that the energy is greater. It hovers around about the 10 to 10.2 foot-pounds of energy region for about 1840 and shot number 80 to 90. And just as the graph is finishing there, when we run out of pellets, we can see there's a sudden jump in energy. Further pellets and testing would be needed to confirm what happened after this, but it does look like it would have a slight increase in energy and would probably tail off after this quite dramatically. So in conclusion, looking at the results we have from this experiment alone, we can see that the energy output did in fact increase by approximately 1 to 1 and a bit foot-pounds of energy, purely down to the enlarged transfer port size. Some interesting things to note about this, essentially, is that we increased the transfer port size diameter by 75%, which increased the cross-sectional area of the transfer port and the transfer port only by about 206%. This was initially thought to maybe give us a lower shot count, since we're using more volume of air per shot. However, if we look at the tube cylinder pressure at 1850 psi in the stock test, we had shot 70 shots. Once we had replaced and used the larger transfer port, 69 shots took us the same pressure. And again, if we look at a slightly lower pressure range, the stock transfer port took 100 shots to get us down from 2800 psi down to 1450 psi, whereas the enlarged port test B took only 89 shots to get us from 2800 psi down to 1400. So in that lower pressure range of 1400 psi, there's an 11 shot difference, which I think the benefits gained from this transport port open up or increased size doesn't take away much air efficiency. At that range, we're looking at 11 shot difference. So in conclusion, from the results we have from this test, we can quite safely say that the energy output of the Gamo Phox Mark II was increased, while simultaneously taking very little away from the air efficiency usage. I'd like to leave you all now with a graphic generated by ChatGPT that was the main outcomes of this experiment. Feel free to check it out. Thank you guys for watching. See you in the future.